Alright, welcome to video lecture 5. We're getting on up there in numbers. We left off with Blu-ray and lasers. I was about to talk about formats. Now, when high-definition video discs came out, there were actually two major formats that first came out. One was, of course, HD DVD, and the other was Blu-ray. Now, this was something that doesn't happen often. There's always a few little small battles between formats, but this is one of the first major fights between mostly corporations. Blu-ray was endorsed by Sony, whereas HD DVD was Toshiba, Microsoft, and Pioneer. Now, even went so far as to say that Pioneer is not going to make anything other than HD DVDs. Microsoft was making HD DVDs as well. Now the discs were comparable size. These high definition video discs are, very sizable compared to the old DVDs. Speed, everything was pretty much the same. Of course, if we look at things in hindsight, I can ask the question, who won? And I wait a second, and the prevailing answer will most likely be, well, Blu-rays are at Walmart. Yeah, so Blu-ray won, HD DVD didn't. So how did Sony, one company, beat three fairly sizable companies? Microsoft being a fairly large giant, Toshiba is a big computer industry giant as well, and of course Pioneer. So how is it that they managed to win? Well, first and foremost, why did Blu-ray win? Well, money does come into play in this. Whenever a new technology comes out, doesn't matter what it is, if it's brand spanking new, it is expensive. Let's take 3D TV, for example. You can buy a 3D TV with 3D glasses and stuff right now. It is stupid expensive, and there's only a handful of things that run on it, but you could buy one. Eventually, the price will come down and it'll be a little more reasonable. The technology will probably get better to where you don't need special glasses or anything like that. Well, with Blu-ray and HD DVD, the players were, $700, $1,000+ for a player. And there were people who bought them, because that's what some people do. The newest thing comes out, they buy it, just say they have it. Now, of course, the prices were comparable too. So why in the world would Blu-ray win out over HD DVD with, 3 or 4 different companies backing them? Well, the simplest explanation would be games. You see, Sony released the PlayStation 3, which had a built-in Blu-ray player. This was $600 or so, I think. And significantly cheaper than your normal Blu-ray player, your normal HD DVD player. And it plays games. And of course, PlayStation's name, they sold 10 million of these units. The number of HD DVD players that were sold, period, was around 1 million. They completely destroyed them as far as that goes. So everyone who had a PlayStation is like, oh, I could watch a Blu-ray, and they bought Blu-rays. And this is how Blu-ray ended up completely, stomping the others. Microsoft actually had HD DVD in their Xbox, if I remember correctly. But doesn't matter so much now. All that technology, that particular format's gone. Now, Blu-ray is pretty much the only thing. Now, you may ask the question at this point, what's the difference between a DVD and a Blu-ray? Why do we need another disc to hold video and things like that? Well, remember, a DVD is a digital video disc, right? An HD DVD is a high-definition video disc. So let's explain a little bit about what that is. High definition. What's that? Now, as you can see from the picture in this background here, I took this picture. That's my little baby Zoe, actually. It's got a lot of colors. It looks nice and sharp and clear in most places. Basically, what high definition is the higher the definition, the better the picture can look. The lower the definition, the kind of crappier it looks. Case in point, this is Zoe playing in a ball pit. And there's lots of colors and it does look pretty nice, right? Here's another picture. Not so high quality, as you can see. Her face is a little blurry in places, you know. Still not a horrible picture, but, I mean, still, you can still see it's a little blurred. Not quite as sharp as the other one. So let's explain the difference between regular definition, high definition, for example. Our picture here. We're going to talk about pixels. Now, I'm going to zoom in on her shirt right here. And you can see this is me zoomed in on the shirt. Now you may notice that there are little bitty squares here. Each one of these is a pixel. Now, if you zoomed out, every picture that's displayed on your screen is a simple dot of light, or a pixel. Same is true here. Every one of these represent, you know, a dot of light. Now, pixels, again, little squares of color or dots of light. All of these comprise a picture. The more pixels that display in a picture, the clearer it is. Also, the more data it needs. That means that it's going to take up more space. Now, regular DVD didn't have anywhere near the pixels that HD DVD does. So the picture is way clearer, way sharper. Sometimes it can almost look like you're looking through a window. That's how clear and sharp it is. Now, standard definition, you know, like 640 by 480, you'll see these resolutions, as they're called. And 640 by 480, if you multiply that, you'll see it's 307,200. That's how many pixels can be displayed on the screen with that resolution. A fairly normal resolution, you know, a few years ago, was 800 by 600. And this is 480,000 pixels on the screen. This is a fairly standard computer screen resolution. Your TV actually is a good bit more than that, but not much. Now, an HD channel that's in full HD is 2,073,600 pixels. Now, the more dots of light you have, the sharper something looks. So as you can see, if I zoomed out of that picture, you could see that the shirt looks pretty clear, but as I zoom in, I've got less dots of light to make up the image, so it's less sharp, less crisp, not quite as nice. Now, of course, that does cause a few problems in some industries, like whenever you see an actor or actress on screen, if they're in an HD movie, they have to do a load of editing, because, you know, regular pictures, regular movies, don't show all the little tiny defects that actually exist in all these celebrities that we see. That aren't, you know, they're going to have to spend a lot of time photoshopping that stuff out, just because the images are so clear and crisp. That's one reason, if you ever met a celebrity in person, you might find they look a little bit different, because virtually everybody is photoshopped. Do you ever see any before and after photoshops? I mean, it's astounding how different, you know, they look. Now, that's high definition. And of course, more pixels would require more storage space, which is why you need a larger disk, because it's easier to store, you know, a few 100,000, 500, even 700,000 pixels on a smaller space. But when you have 2 to 3 times the information, it takes a little bit more room to represent it. Now, other storage devices. This is your standard hard drive. We've already seen a picture of the same thing, well, the other side of it, but this is what's normally in every single computer. This is where most of your data is stored. Magnetic disks that spin around, physical moving parts. They can be up to, you know, 2+ terabytes right now, which is a fairly substantial amount of information you can store. This is usually inside your computer, but you can buy some externals to plug up to your USB ports and stuff like that. Now this is a flash or USB drive. Most of you hopefully should have one of these. And this is one of the nice things about this is you can just plug it up to a computer, save files on it, unplug it, and plug it somewhere else, and your files move with you. So it's a very quick and easy way to store data, and a fairly sizable amount of data. These things can get upwards to the hundreds of gigabytes of data. This picture is only 4, but still that's, if you think back to the floppy disk, that was 1.44 megabytes. That's infinitely larger than that floppy disk. In fact, this flash drive right there that you're seeing on the screen, my first hard drive was 850 megabytes. This is 5 times the size of that. My hard drive was, a standard hard drive size. This flash drive would probably be about here in length in that hard drive, and yet it holds that much more information. Now you also have SD and flash cards. These are typically the same kind of technology you actually see here, except for the fact that they're smaller. These go into cameras, phones, and things like that. Again, you have a couple of gigs. They can go up to, I actually don't know, 128 gigs or thereabouts maybe now. I haven't looked in a while. They can get pretty sizable. And last but not least, SSD drives, otherwise known as solid-state drives. Now, I told you before that the regular hard drive, like you see here, is kind of old and antiquated. It's more than half a century old now. And there are better things that exist. Well, this is one of those better things. A solid-state drive is significantly faster than a regular hard drive. We talked about defragmenting before. The solid-state drive, you don't have to do that. It automatically defragments. You don't have to think about it, because it will do it automatically because it's that fast. Now, I'll just explain the difference in speed. Your regular hard drive, let's say you boot up a computer and you have a regular hard drive. Maybe it would take 20, 40 seconds for your computer to boot up. If you compare that to a solid-state drive, 8, maybe 10 seconds at most, before everything's booted up and ready to go. Now, you may think, well, why isn't this in every single computer? Well, 2 reasons. One, it's a bit more expensive. I can buy a 2 terabyte hard drive for 80 bucks or less. I can buy a 200 gigabyte solid-state drive, which is, a 1/20th or 1/10 rather, the size of the hard drive for $150, $200 maybe. So you get significantly less space at a significantly higher price. Now, of course, it's immensely faster, but it's more expensive. So you have more expensive and less storage space, which is why you don't see it as much. Most people will use this as, well, the drive that just holds their operating system on it. Windows or Mac or something. And then they'll have another one of these just to store all their files and data they don't really readily need. The nice thing about this is there's no moving parts. In fact, if you put it in a laptop instead of a regular hard drive, you'll actually find your battery life is extended quite a bit because nothing moves, nothing spins. It's just like one of these other things, flash drives. It's just a card inside there that it reads from the little repository. Now, I believe that is all of our storage devices, except for one. The cloud, you may have heard of. Everyone's always talking about the cloud this and the cloud that. So let's talk about the cloud. The cloud has swords and looks up to the sky and stuff. Alright, wait, nope, different cloud. The cloud, okay. The cloud we're referring to computer-wise. Basically, it allows you to connect to things through the internet. Other devices, data storage, things like that. The cloud is effectively, a little interface, or the internet itself. You can plug in your laptop, and if you have a service or something, you go through the internet, through that service, to get to printers or whatever else you need. A good example would be, not that long ago, a lot of people were saying that Apple's cloud storage was hacked and all these celebrity pictures were stolen. Well, basically, there's a physical hard drive somewhere in some server farm for Apple. Now, whenever your cell phone takes a picture, it gets uploaded to the internet, basically, and uploaded to that server. So it's not physically on your phone unless you just save it there. It's on another device in a completely different location. Now, as far as security goes, Apple and whatever company is there is supposed to have little walls up to prevent people from getting to it. But somebody figured out a trick to get in there and get whatever files they pretty much wanted. So they were able to go through the whole list and just snatch whatever. But cloud storage doesn't necessarily have to be dangerous. I mean, if you take a bunch of disturbing photos of yourself and you're just asking for somebody to go and look at them, even if you hide them in some creepy folder on your hard drive or something, eventually somebody's going to find them. And you definitely don't want that to make it to the internet, because once something is there, it will never go away. Now, a cloud would allow me to hook my laptop up, and I could print to a printer in another location. I could, access my hard drive at home or something like that, or even access another computer. That's effectively what the cloud allows you to do. I could save files on the cloud. In the future, this may be how everything is pretty much wired. In fact, if you wanted to download and install a game, well, you wouldn't download and install it on your computer anymore. You would download and install it on some machine somewhere else. I could potentially see this be a model, for a business. Someone pays a good bit of money to have some souped up computers, and all you have is a cell phone or a little tablet or something, and you just connect to that computer and they just send you the information back. So you're remotely playing this game on another computer. The internet's not quite up to speed to do that right now, and we'll get into issues with that later. But eventually, that's probably how it's going to be. You'll have a little tablet or a little handheld device that can do just about anything, because nothing's done on the device itself. It's always done remotely on a much more powerful machine. Now, that should be it for our data storage. Next up is going to be communication devices, which we're going to talk about in the next lecture. So we're going to pause right here.